the data set. This data set has been extracted from Kaggle and it contains around 40 million products that is available at cdiscount.com. It's categorized in a three-level classification. So there are like 12 million images for 7 million products. And it comprises of the following three files: the train.bson, the train example, and the category names. So the first step was the data ingestion and the pre-processing. So we have sampled the original data to a size of 10,000 entries and made use of the following Python codes. So we'll shift to the Jupyter notebook for that. So yeah, the first step is importing the necessary packages, then decoding the BSON file. So you initialize a counter and set an empty my data list. Then you extract the products until the counter reaches a value of 10,000. Then the next step is converting the BSON files to data frames. We do this in the following way, and then we display the first 50 records for that particular data frame. We then categorize the images as a separate data frame in this manner. The next step is to read the images file as a CSV file, and then we try to load the images from that CSV file in a separate directory. This is what this code does. And when we go down, we see the number of images that are stored at this folder, and it's around 10,000 images. So then we start with the similarity search algorithm. The first algorithm is the cosine similarity algorithm. This measures the similarity between two vectors of an in a product space, and it is a measure of the cosine of the angle between the two vectors and determines which whether two vectors are pointing in roughly the same direction. And it's often used to measure documents that are having similarity in the text analysis. So it is a metric that's used to measure how similar the documents are irrespective of their size. And this is a Python code that we have used. So we'll shift to the Jupyter notebook for that again. Yeah, so first we start by importing the necessary packages. Then we load the images from the already pre-processed images. We see that it founded 10,000 images, and then we create a function that's going to implement the similarity search. So this is the function, and as you go down, we can then evaluate the function against a particular image. So if you search by a specific style, so if you call this function and pass this image as the input, we can see that these kind of similar images have been generated. And we have also calculated the cosine similarity distances in this notebook, where we are searching for again implementing the same thing, but over here as you go down, we are saving the output to a CSV file. So this CSV file will later be used when we implement the Streamlit applications. So yeah, we are saving it to a file called method1.csv. So second similarity search technique is the Facebook AI similarity search using FAISS. So it's a library used for efficient similarity search and clustering of dense vectors. It returns all the elements that are within a given radius of the query point. The vector representation for images is designed to produce similar vectors for similar images where similar vectors are defined that are nearby in Euclidean space. So the implementation starts by getting the Docker running. So we need to make sure that your Docker is running. You can do so by checking if your Docker, like in my the Docker is running. So yeah, and I've also started the terminal over here by implementing the following three commands. So start by first loading a repository, then changing the path to the visual search, and then calling the Docker compose. So when you do this, we are redirected to a directory to a particular URL over here. So you can implement the visual search over here. So you can select an image from the box. Let's say um, image of a chair. So when you click this, select this image, it will generate the relevant images of a chair. And you can also do the similar function by making use of an URL. So I have a URL opened over here for a particular black chair. So I'll copy this image address and paste it over here. So as we can see, similar kind of traits have been suggested over here. We then move on to the Spotify Annoy method for visual search. So the Annoy is an open sourced library for finding approximate nearest neighbors. It builds an Annoy index by appending all the image feature vectors that are stored in the local folder. And we'll move on to the Python implementation for this. So again, it starts by importing all the necessary libraries or installing all the dependencies, setting the image paths. Then we load the image using this function. We then make an image to vector conversion by calling this function. And so this function will generate the feature vectors for our images. Then we start with the Annoy implementation where we first load the JSON file and then call this function, the cluster function that will generate the Annoy indexes for a particular images. So this is the output when you call the get image feature vectors, and this is the output that is generated for the cluster function. So then we finally start with the Streamlit application, wherein we make use of the CSV files that we created earlier, and we make in this app we have made use of the cosine similarity and the FAISS in the Streamlit application. The cosine similarity implementation. So I'll jump to the implementation then. So we have hosted the Streamlit application on Heroku. So I'm going to launch it from the Heroku website. It's taking a bit of time to connect. Yeah, so over here you can choose the type of search method that you want. So by default it's cosine similarity, and you can select an image from over here and it will generate the number of similar images. So you can also give a filter if you want like 3 similar images or 5 or 10 similar images. So you'll get the output below. You can also choose the similarity method to be the FAISS, where you can all like similarly you can select the images and it will generate the specific outputs. So all this is done by running the .py file in the Streamlit application and then hosting it on Heroku. So yeah, this is the implementation for similarity for the Streamlit application, and the conclusion, like we generated the application that will implement the cosine similarity algorithms. Then we also demonstrated the use of the Spotify Annoy method to generate the indexes and feature vectors. We then also made use of the Docker application to generate similar images based on a particular image uploaded from a local machine or the web URL. And these are the references that we have used.